this presentation. And today's presenter will be Mr. S. Saravanan, and he'll be saying about. So thank you all for coming. So please wait till 5:30 so that we'll start the meeting.
But ammonium nitrate. So basically, it is a chemical reaction between ammonium of your ammonium to ammonium. What's that?
Good evening to all. I think like it's time for us to start. So now Mr. Saravanan will take over. I
Yeah,
welcome
thank you.
everyone.
Yeah, right. Good evening, and this is Solonan. Just I'm in front of you. I'm Solonan, and I will be very happy to interact with you all. So let's I share you my thoughts about the ammonium nitrate. This is what that exploded last week in the capital city of Lebanon-Beirut. Right. I hope you all are here. What I'm trying to say to you. My pronunciation is somewhat entirely different. So if you have any ambiguity, then kindly type your views to the host or to me. Thank you to cooperate with me. Let's we will see what is happening, which means what is the chemistry that is behind the Beirut explosion. Let's watch. Okay, right. So Beirut explosion and its chemistry. Right. So So first thing I want to emphasize was the interesting fact about the ammonium nitrate. Because most of people are unaware about the ammonium nitrate because most people see that it is highly explosive. When it reacts with other compound, it may easily catch us fire. Actually, that is not correct. The, the temperature, the decomposition temperature of ammonium nitrate is barely 200 around 260 degrees Celsius. Let's say explain you the interesting facts about the ammonium nitrate. Right. This is the first picture I want to show you. Right. Okay. Ammonium nitrate. Ammonium nitrate is a crystalline white solid. It is made in large quantities industrially by the reaction of ammonia with concentrated nitric acid. Just in order to explain very clearly, just I wrote it to you. This is ammonia, right? And this is your nitric acid, and we will enter with this ammonium nitrate, right? Okay. Next, I explain you the uses of the ammonium nitrate, right? In your PowerPoint, I written it you, right? Right? It is ammonium nitrate's major use in fertilizers as a source of nitrogen, and it is also used in some exploration mixtures for mining and quarrying as an oxidizing agent. Right. Okay. The uses of ammonium nitrate in worldwide mostly it is used for only for agricultural purpose. For example, 78% of our ammonium nitrate to be used for agriculture purpose, whereas only 22%. Once again, I repeat you, only 22% is used for the explosive purpose. So you must aware about that. And the next reaction. So this is not something very important. This is what happened in the Beirut, the capital city of Lebanon, right? Okay. So the ammonium nitrate is there. For your understanding, just I round a bit. Ammonium nitrate is there. When it decomposes, it gives 2 moles of nitrogen, 4 moles of water, and oxygen molecule. Right. Okay. So various other reactions occur during decomposition. This makes other gases such as nitrogen dioxide. So this is what, and this is mainly responsible for the red color of the blast. So most of viewers asking about the color of the blast. It is in a blood red color, right? The reason for the blood red color is due to this nitrogen dioxide. So once again, I repeat you. And the ammonia, right? This is what you know that already. Nitrogen dioxide causes the orange red color. Just know the color, right? It is orange red color, sometimes seen in smoke from this explosions. So this is what I want to stress you. And the next slide is about the decomposition. Decomposition. This is what I want to explain in a very detail, right? Pure ammonium nitrate does not explode easily, right? Right. Note the word does not explode easily because it only explode at 260 to 300 degrees Celsius. Only at that temperature, okay, right, it will explode. Otherwise, it will not explode. So people, you must know that, okay, right, and can be handled safely. The risk of explosion increases if it is contaminated with impurities, and that is the main reason for Beirut explosion, right? So impurities, simply the impurities reacted with your ammonium nitrate. So that is the reason for the explosion in Lebanon, Beirut in Lebanon, right? It decomposes at high temperature and is confined and explode. So from that, we have to come to conclude that it is not automatically exploded. When it reacted with the impurities, there are so many impurities, even a little bit of fluoride which means in chemistry we call it as a halogen, right? Okay, even it is oil, when it even an oil, okay, right? Oil, whatever it may be, oil, when it reacts with ammonium nitrate, it will easily capture the fire. The temperatures may rise to this 260 or 300 degrees Celsius. That is the only reason for this explosion, right? When ammonium nitrate decomposes, it primarily breaks down into a number of gases: nitrogen, water vapor, and oxygen. There is a rapid release of gas gases and explosion. In addition to that, uh, in addition, sorry, in addition to that, I want to stress some point about the interesting factors about the ammonium nitrate. So it is usually derived from and is derived from the reaction between ammonia and nitric acid. It contains 33.5 to 34% of nitrogen, of which half is in the nitrate form, which is easily assimilated by plants, and half is in ammonia form. Right, okay. It is used principally as a nitrogen source in fertilizer and is the main component of most non-military industrial explosives and blasting agents. So once again, I repeat to you, it is mostly mostly a non-military interior explosives and blasting agent. So there are three types of ammonium nitrate. Once again, I repeat to you, there are three types of ammonium nitrate. So first one is fertilizer grade, and second one is explosive grade ammonium nitrate, and third one is solid ammonium nitrate. So one interesting factor I want to emphasize in this occasion is, so fertilizer grade ammonium nitrate, already as stressed, has a slight higher density, which means it has a slightly higher density than explosive grade ammonium nitrate. Right, okay. So solid ammonium nitrate is particularly gains important in developed countries because of its storage, right? Okay. So how it is used is, it is used as a urea ammonium nitrate solutions, which means UAN, right? There is a continuous pressure, I'm very sorry, there is a continuous pressure around the world to regulate use and trade of ammonium nitrate because of its potential for misuse. So there are a lot of happened. I don't want to stress the incidents, okay, right? It is purely on, this discussion is purely on science. So there are a lot of potential issues out there as an explosion in terrorism or for accidental detonation. Several countries have banned the sale of ammonium nitrate as a fertilizer, including Afghanistan, China, Colombia, Philippines, and Turkey. The sale of pure ammonium nitrate has been banned in countries, so many countries, such as, one such example is Australia, Germany, Ireland, even in Pakistan and the United Kingdom. So next I come to India. Okay, right? Whereas in India has reclassified it as it is an explosive. Once again, repeat you, India has reclassified it as an explosive, so which has tightened the regulations. The central government has tightened the regulations, okay, right, related to handling and storage. So this has negatively impacted the consumption growth on a global level. Right, okay. So next I move to the ammonium nitrate consumption and its applications. Right. Ammonium consumption is broken down as 78% for fertilizer applications and 22% for explosives. As already I told you, a large portion of ammonium nitrate consumption in fertilizer application is in the production of urea ammonium nitrate. So once again, I repeat you, a large portion of ammonium nitrate consumption in fertilizer applications is in production of urea ammonium nitrate. Why people are so much interested with urea ammonium nitrate is, so the side product of urea and other nitrogen solutions. And another one is, the following its commercial evaluation after the World War II, ammonium nitrate supply grew steadily for many years, and the ammonium nitrate market is now mature. Once again, the primary nitrogen fertilizer product that I was already emphasizing, which means the urea ammonium nitrate. Ammonium nitrate has lost its position to urea, which has a higher nitrogen content, is more stable, has a lower transportation content, nitrogen content basis, and is often less costly to produce. So ammonium nitrate is expected to continue to lose market share during 2019 to 2024 as more consumers switch to urea or use urea ammonium nitrate solution. The reason is ease of handling and the safety when you compare it to the pristine ammonium nitrate. Okay, right? So nowadays people are moving to urea ammonium nitrate because of its easy handling and safety. Right. Okay. Then next I move to the statistics point of view. World consumption of ammonium nitrate and ammonium nitrate. So just look at the bar diagram, right? just try to concentrate on Eastern Europe, right? For your example, for your convenience, just have insert Eastern Europe. The next one is Western Europe and the United States. United States. So these three countries, right? Okay, these three countries are the leading consumers of ammonium nitrates, right? In 2019, right? Just as I said you, in 2019, these three regions together, which means Eastern Europe, Western Europe, and United States, these three regions together accounted for about 53%. And once again, I repeat you, 53% of total world consumption, right? Consumption is forecast to increase at an average rate of 1.0% during 2019 to 2024. Growth in consumption will be driven by Eastern Europe, right? Okay, Eastern Europe. Then once again, I repeat you, Eastern Europe, China, right? Central and South America, right? Central and South America, right? Although the consumption of ammonium nitrate varies by region. This is what you must know that. The reason is the world average is 78% in fertilizer application and 22% in industrial. Hope once repeatedly I will stress this point. The other viewers may word about that, but I'm very sorry because it is very important. That's why I repeated. Right. Explosive application. Some ammonium nitrate is consumed in the production of nitrous oxide, which are used as propellant. The aging population in advanced economies like India will result in increased nitrous oxide demand in the pharmaceutical industry. And people, you all know that we are the leader in the pharmaceutical industry, right? The semiconductor industry will also see rapid growth in nitrous oxide using chemical vapor deposition, diffusion, rapid thermal processing, and chamber seasoning applications. Explosive applications account for nearly 98% of industrial applications, with the production of nitrogen oxides accounting for the remaining 2%. So this is the economic aspects of ammonium nitrate. Right. Next we move to the crux of the today's seminar. That is the frisky chemistry of ammonium nitrate. Right. Okay. So right, I have some problem with this. Just right. I'm very sorry. Just right. Just right. Sorry, I have a low bandwidth for 14 minutes. But okay. Next, we move to the frisky nature of ammonium nitrate. But okay. Every fire is a rearrangement of molecules, and an explosion is basically a fire turbocharged into a hyper energy fueled frenzy. Unstable structures, batches, and swap atoms with one another until all of them, happy with their traders, blissfully settle into more relaxed, lower energy states like the rocks reaching the bottom of it. But their excess energy has gone to somewhere. In a campfire, right? We have already had such an experience, right? So in a campfire, right? In a campfire, where the chemical reactions are facilitated in a leisure way, right? By the oxygen in the air. Energy is released slowly as enjoyable levels of heat and light. Right. In an explosion, however, the device literally was instigated, that is oxygen, shows the process into overdrive. Right. Okay. Early reports of the blast revealed that the building that sparked the eruption may have been storing large quantities of ammonium nitrate, a flammable chemical that has relatively harmless, once again I repeat you, that has relatively harmless manifestations as fertilizer, but has also been experimented with as a rocket fuel. Oxygen is the key to ammonium nitrate's deadly habit of exploding. Right. Once again, I repeat you, oxygen is the key to ammonium nitrate's deadly habit of explosion. Right, okay. This is what I want to show you. And given that the 47 known major accidental ammonium nitrate explosions have occurred in the last century. Right. So this is the decomposition reaction. Ammonium nitrate is there, right? Okay. So we get nitrogen, water, and oxygen. Along with that, we get ammonia, nitrogen dioxide, and nitrous oxide. I already specified that the reason for this orange red color, some may call it as the blood red color, okay, whatever it may be, but I leave it to your discretion. But the reason for this red color, right, once again I stated you, the reason for this red color is due to this nitrogen dioxide. This is what happened, right? This is the reaction, but you may ask about that, where is nitrogen dioxide? So along with this reaction, this is also nitrogen dioxide, ammonia, and the nitrous oxide are the byproducts. These are responsible for this red color. Let's explain to you chemistry in detail. So ammonium is nothing but NH4 plus, right? Here I write you ammonium. This is NH4, right? NH4 is that, whereas the nitrate, okay, right? Nitrate is NO3 minus. This is the nitrate, NO3 minus, right? Okay. Under boring everyday conditions, some may feel that this is also my board. Okay. Conditions, the ammonium and the nitrate ion, right? Okay. This is ammonium. This is ammonium ion. This one is nitrate ion. Pull the two molecules together, harmless, heavy. But when you add a spark, right? Once again, I repeat you, this ammonium NH4 plus as well as NO3 minus. This is ammonium ion. For example, this NH4 plus is ammonium ion, whereas your NO3 minus is a nitrate ion, right? Okay. Pull the two molecules into a harmless. But when you add a spark, right? Okay. Suppose, for example, if you add a spark, right, or a firework. Next one is firework. Suppose if we add a spark or a firework between these two molecules, the molecules realize that the very atoms can get a little prepared and convert into something completely new. Okay, when completely new, this is the chemistry behind that. And nitrate, when mixed with glow, wants to pitch those little oxygen. It is chemically unstable, meaning the bonds between the nitrogen and oxygen vibrate with an unhappy level of physical tension. Overload with the 3 oxygen in NO3, right? Okay, overloaded with the 3 oxygen in NO3 is eager to show some onto any neighbor, and with a little bit of heat to get this moving, it will do so willingly. NH4 plus ion is all too happy to accept the chemical rearrangement of ammonium nitrate. This is a lot of public questions about the videos, including the source of starting the red color of the pen. Now you people are aware about that. The red color of the flame is due to this NO2, right? Once again, I repeat you. Just what I'm trying to say to you is the red color. This red color. Next time, move to the slide. The red color. This red color is due to NO2, right? Okay, NO2. Okay, this nitrogen dioxide is responsible for, right? Okay, nitrogen dioxide is responsible for this blood red color. Okay, so now I explain it to you. Right? Red color of the thing. One of the byproducts of NO3, I'm very sorry, NO3 minus, very sorry, NO3 minus, as it sheds all that oxygen as nitrogen dioxide, this has a logically outward chemical structure, which goes to like NO2, right? Okay, and looks deep blood red. Okay, once again I come to the point. The crux of the point is this color is due to, right? Okay, this color, which means the NO2, the blood red color, which means the deep blood red color is due to NO2. This NO2 is responsible for this deep blue red. Many explosive materials give off tints and hues during a blast that subject to a chemical composition, chemical additives to color both smoke and explosion have been around since before the 1920s and are how we get different colored fireworks and signaling flames. And it is nitrogen dioxide, right? Okay, this nitrogen dioxide that gives an ammonium nitrate explosion. It is signature, ominous blood vacuum. Small blast can look subtle and orangish, but on large scale, like at Beirut, the sunlight is deepen its hue. Right. Okay. Usually it is orange in nature, but suppose if the storage is very large, like at Beirut, the sunlight has deepened its hue. Right. According to some statistics, right? Okay. According to some statistics, sunlight, right? Okay. Sunlight bounces around within the cloud of contaminants. Other less determined wavelengths get refracted out of in different directions. When the smoke film happens on such a large scale, only the largest wavelength, the red shade, pushes all the way through to the river on the other side. So the natural reddish color becomes even deeper, richer, darker it would be for a small blast. An explosion with a pure burn, like any explosion either in military weaponry, will produce smoke that looks equally pure, snowy, billowy white, or sometimes a pale gray. But accidental explosions are far less steady, and the sloppy combustion also produces ashes, particulates, and gross black charred contaminated matter. This black gunk billows into a sky along with the other byproducts, coloring the smoke clump like charcoal residue left behind after the more efficient parts of the campfire wood have burned away. To a blast expert, the videos whether they are rolling cloud of black and red curling over the Beirut street ammonium nitrate. And the next rumor is also in social websites and other things is shockwave. Okay, right? Actually, it is not a shockwave. Let's give me a time to substantiate my statement. The video also shows an unnervingly uniform hemisphere of white propagating outward from the blast. So what I'm trying to say to you is this is what I'm emphasizing. A dome of vicious vapor that eventually causes towards every person, filming and announcing its arrival in the audio with a crash. This hemisphere is the pressure wave produced by the explosion. So that white propagating outward from the blast side is due to the explosion of ammonium nitrate. No, it is not a shock wave. Already I stated it to you. It is a pressure wave. So this is nothing but a pressure wave. Okay, right? And this is nothing but a pressure wave. So this is what I am emphasizing now. Right. Pressure wave, and that key difference affects the number of casualties expected. A shock wave goes from zero pressure to its absolute maximum pressure in literally 0 seconds. The impact of a shock wave, right? The impact of a pressure wave is like hitting the ground after rolling down a steep cliff. Geographers may know the term cliff. The force of a shock wave is like hitting the ground after falling through the air and reaching the terminal velocity. Right. High explosives produce shock waves. Low explosives like ammonium nitrate. Then once again I repeat you, high explosives produce a shock wave. Usually it will produce a shock wave. But in the case of ammonium nitrate, produce pressure wave. So you must know that. First, most of videos circulating around the social media, they say that it is a shock wave, but actually it is not a shock wave, it is a pressure wave, right, which have a bit of slope of the shape, a period of time over which the pressure increases more gradually. Sure. Because of their fascinating and complex physics, travels faster the speed of sound and they cause far more damage than pressure waves. Thankfully, we know this blast did not produce a shock because the speed of the water vapor filled with white dot can be measured. The speed of sound in air is 343 meters per second. Based on the viewing angle and distinctive red charts pictured in some of the later films that I show it to you in your PDF. Okay, right? Its filming location on the rooftop terrace of and building and measured it to be 885 meters from the center of the blast. Right? Once again, I repeat you, 885 meters from the center of the blast. From the vantage, the pressure wave can be seen neatly traveling from the center of the blast first to the point orbit between the end of the field and edge of the long, massive great brain pillow building at distance of 151 meters. Then to the end of the pier, 262 meters, then eventually to La Maquilea. Right. By measuring the times at which the pressure wave reaches its landmarks on the video, we know that as it passes down the field, which is rampage, at a speed of only 312 meters per second. That is known for a bomb. Then by the time the audible crash and mayhem reach the family, someone is interrupting. formally, peacefully, and picturesquely outside bar. It has flowed to at most 289 meters per second. The pressure wave slower than the 343 meters per second speed of sound, caused the destruction, horror, confusion, shattered glass, torn apart surfaces, and disorientation from onlookers as their ears were subjected to the rapid pressure fluctuation. But a shock wave would have caused them to drop dead from lung trauma they watched. In the 6 million pound Halifax explosion in 1970, which means I talked about the uh, sorry, one second, sorry. Right, okay. So let's say talk about the one of the histories, right? In the Halifax explosion of 1917, the propagation of the shock wave through a downturn left a slack of fatalities reaching 1 miles from the center of the blast, killing an estimated 1,950 and leaving another 8,000 with devastating injuries. Right. Okay. So, and the next I move to the thanks to modern technology, that the charge size can be translated scientifically to, even while waiting for more complete information to check it out, using the size of the skeleton crater. Analysis of the aerial photograph of the face shows a crater in the range of 120 to 140 meters in diameter. Blast physicists, with history, tell us that to carve out a chunk that size of the side of the planet requires a charge equivalent to 1.7 to 5.4 million kilograms of TNT. And we already know that TNT is nothing but a dinitro that is 3.8 to 11.8 million pounds for any Americans tracking the effect on converting to metric scales. Right, okay. And the next, I move to emphasize on and another interesting fact about that, it is registered at 3.3 magnitude on Richter scale. Resulting shock wave moved faster than the sound. Actually, it is not a shock wave. Has a typo with my PPT. Actually, it is a pressure wave equivalent to 300 to 400 tons of dinitro-toluene. The ammonium nitrate in Lebanon is Lebanon in the name of is stored in the name of nitrate. Okay, in the right? That is nothing but a nitrate. Right. Okay. While we do not know for sure what caused the explosion in Beirut, footage of the incident indicates it may have a big set off fire visible in a section of the city's sports area before the explosion happened. It is relatively difficult for a fire to trigger an ammonium nitrate explosion. So once again, I repeat. So it is relatively very difficult, very difficult for a fire to trigger an ammonium nitrate explosion because its detonation temperature is around 260 degrees Celsius to 300 degrees Celsius. The fire would need to be sustained and contained with the same area as the ammonium nitrate frills. Also, the frills, which means frills is nothing but the fillers, I want to mention, themselves are not fuel for the fire, so they would need it to be contaminated with or packaged in some other combustible material. And that is the reason for the blast in Beirut, in the capital city of Lebanon. And next we move to the ammonium nitrate regulations in India. And this is not something very sensitive topic. I don't want to enter into any what I'm trying to say is any controversies. So ammonium nitrate regulations in India, right? Okay, right, there are two regulations out there. One is Explosive Act 1894, and another one is Ammonium Nitrate Rules 2002. Right. Okay. Right. The two regulations control the ammonium nitrate explosion in India. So our laws are very strict. Without permission, we cannot store ammonium nitrate. If someone is stored that, it will be strictly viewed as well as those persons are strictly prosecuted. Right. Okay. And next one is past history about the ammonium nitrate explosion. And this is the video. Just look at this and this is the PPT. Just look at the PPT. So just in this case, I want to emphasize in 1947, the Texas explosion. This is what I'm very much interested. Right? Okay. One of the deadliest explosions caused by ammonium nitrate took place in Texas City in 1947. So this is what I want to emphasize with you. A fire on a boat of a ship carrying 2,300 tons of fertilizer caused it to detonate, killing at least 500 people and creating a 15 foot, which means 4.5 meter tidal wave. The blast further the ship anchor, weighing 1.5 tons, 1.6 miles away. The accident prompted a new regulations for the manufacturing and transport of chemicals, in particular requiring safer containers for ammonium nitrate. This has not prevented the further disasters. Just to see your PPT. In 2004, let's say move to the 2004 incident, right? Okay, miserable era, right? Okay. So the interesting case is a freight train carrying the chemical exploded in Iran, killing 300 people and destroying a village. Just think about that. And 173 people, many of them firefighters, died in Tinajan and China's northeast coast in 2015. So these are all are examples for major chemical ammonium nitrate explosions around the world. When chemicals including ammonium nitrate exploded in the port city, in the aftermath, protesters accused the authorities of being secretive about the cause of the blast and who was to blame. The explosion in Beirut appears to have been caused by a store of ammonium nitrate that had been unloaded from a ship in 2014 and left in a warehouse. And one more interesting point I want to emphasize was the Hiroshima bomb had a force equivalent to 15,000 tons of dinitrotoluene, whereas the explosion in Beirut was probably closer to a few hundred tons. The deadliest man-made non-nuclear, once again I repeat you, non-nuclear, the deadliest man-made non-nuclear blast occurred during the First World War when a ship carrying explosives detonated by accident in the Canadian port of Halifax, killing almost 2,000 people. So this is for your kind reference. Just look at the PPT and you will know that some interesting rest of the accidents and how it works. Okay, especially what is so just this ammonium disaster started since 1900, and this is for your the death rate is more than 100. Right, okay. And the next one is the inhibitors to prevent the ammonium nitrate decomposition. I think this is the crux of this seminar. Inhibitors, right? Okay. So let's say European, particularly I want to emphasize the European Union Commission's regulations about the storage of ammonium nitrate. Right. So these are the inhibitors, which means what I'm trying to say to you is, suppose if you add these inhibitors along with your ammonium nitrate, we may increase it, just look at the diagram, we may increase the detonation temperature. Okay, right? We may increase the detonation temperature. So these all are called as carbonates. Carbonates. So carbonates are the best inhibitors to prevent, right? Okay, to prevent the ammonium nitrate explosion. Like for example, in this case, the ammonium nitrate is there. Actually, its original decomposition temperature are detonated at 326 degrees Celsius under some suitable conditions. For example, if you add an sodium nitrate along with your ammonium nitrate, then our temperature may barely increases to 2 degrees Celsius, which means 328. For example, if you add a potassium nitrate, the temperature may decrease. So we will leave it because of has a lower temperature. And next we move to the another one is this sodium sulfate. Just look at this sodium nitrate solution, just 349. So suppose there are so many additives are there: sodium nitrate, potassium nitrate, calcium nitrate, sodium sulfate, calcium sulfate, right? Then so many compounds are there. But the very interesting is this carbonate, because the carbonate has a high decomposition temperature. Usually in European Union, the authorities allow the ammonium nitrate storages import along with this inhibitors so that they can raise the temperature. Okay, right? For example, for ammonium nitrate along with the calcium carbonate, 389 is the temperature. So this is what preferred in European Union. Right? For urea, the temperature is 394. So these all are the inhibitors. Just I skip out the HMK because of HMK, there are another problems are there. So these are all some to prevent the to prevent the increases of the ammonium nitrate decomposition temperature. By adding this inhibitors, we can delay the detonation process of ammonium nitrate. This is what I want to try to say to you. Right. Okay. So next is your question and answer. Sure. Suppose if you have any question or suppose if you have any question, then ask me. Then I will be the responsible person to clarify your doubts. Person?
Thank you, Saravanan. I thank him for the good presentation.
Dear person.
And now we know like how
Yeah.
ammonium nitrate can be dangerous also. Now, if you have any specific questions, you can ask him either by unmuting the mic or you can type it out in the chat box.
Right. I'm ready. If you have any question, then ask me. I hope you all are audible. My face as well as my voice are clear to you. Any questions?
Sir, hello. Hello, sir.
Yeah,
I
This
have
is Rahul.
yes, tell me. Hi. Yeah,
Yeah,
Basan?
yeah. Shall I type that in the chat box, sir? Is it audible for you?
Yeah, yes, of course. Yeah, yes, yes.
Yes,
I'm
sir.
okay with
Yeah. In the middle, you said like the comparison of Hiroshima and the Beirut explosion. Could you please tell me that again,
Yes,
sir?
yes.
Because I couldn't hear that properly.
Yeah, okay, right. So what I want to emphasize in this case is, for example, what has happened with what how can I explain it to you as well? Just wait. Just wait, Mr. Robert. Just I will explain. Wait.
Yeah. Okay. Sure, sir.
Okay, Mr. Rahul. Just I explain your question. For example, the Hiroshima bomb had a force equivalent to 15 tons of dinitrotoluene. Right? Okay, Rahul, are you here? Right. Okay, fine here.
Is that
For
15 tons you
example,
said, sir?
yeah, yes, yes. Okay, right. So the
Yeah.
Hiroshima
Okay.
bomb had a force of the Hiroshima bomb had a force equivalent to 15,000 tons of dinitrotoluene. Whereas in the case of
Okay.
Beirut explosion, whereas in the
Okay,
case
sir.
of Beirut explosion, right, it is badly around 300 to 4,000 tons of dinitrotoluene. When compared to Beirut, right, okay, your Hiroshima
Okay.
bomb equivalent had a force equivalent to 15,000 tons of, once again I repeat you, 15,000
Yeah.
tons of dinitrotoluene. Whereas in the case of the Beirut explosion, it is around 300 to 4,000 4,000 tons of dinitrotoluene.
Yeah.
Okay,
Okay,
next
sir.
question
Yeah.
is,
That's clear, sir. Thank you, sir.
okay, thank you so much.
I have one question. Like you were mentioning about difference between a shock wave and pressure wave. So you said like what happened here? It was a pressure wave, but not shock waves. So can you tell me about like what is the difference when we will call it as a shock wave, when we will call it as a pressure wave?
Yeah, of course, good question, Mr. Vasan. Actually, uh, the wave that is caused in Beirut is actually that is a pressure wave, right? Okay, but if it is the explosion, if, for example, how can I say to you is if it is more than, for example, so first of all, on the Beirut explosion is an example for the pressure wave. So the case of shock wave, the impact that created by the what I'm trying to say to you is the impact that created by the exposure may vary depend upon the parameters depends upon the parameters they classify shock wave as well as pressure wave. If it is a pressure wave, it may be caused by some small explosions. For example, in the case of period explosion, it is only around 400 times. Suppose if the explosion caused by more than 10,000 or 20,000 ammonium nitrate exposures, then we can say it is a shock wave because the impact based on the impact on the land we classify into a pressure wave as well as shock wave person. Anyhow, you are asking a good question. I appreciate your person because I feel a little bit clarification. I need a little bit clarification about that. So in future, I will send you the detailed write-up about the pressure wave as well as the shock wave and what are the difference and difference between pressure wave as well as shock wave. Thank you, Vasan. Thank you. If you have any
Sir,
question, another question, then you can ask.
yeah,
Thank you
I
so much.
have a question.
Yeah, yes.
Sir,
Tell me, Mr.
I
Rahul.
have a question. What wasn't
Yeah,
asked
I'm
you
not.
just before? Uh, you there, sir? Hello,
Yeah,
sir.
yes, I'm here. Once again,
Can you
can you
hear me?
repeat me what you're asking? Yeah, yes, yes,
Yeah,
yes. Of course,
I,
I'm here.
I,
I'm here.
I have a question that wasn't asked you from. I mean, I just have a doubt on that, sir. So you said like there are different parameters for pressure and shock waves. So which means what if
Yes.
a pressure wave can create a shock wave? Will it create a
Yeah,
shock
yes,
wave?
of
I
course.
mean, pressure wave
Immediately,
can create a shock.
yeah, yes, of course. A good question. Good question. Actually, the pressure wave is the precursor of the shock wave. So what we are experiencing in the Beirut is, it is only the pressure wave. So from your question, right, from your question point of view, so pressure wave is the precursor for the shock wave. Suppose if the
Okay. Okay.
explosion is happened in a very big way, then we can say this is a shock wave. So the explosion happened in very small nature. So from that, what I want to say to you is the pressure wave is the precursor for the shock wave. This is what I want to
Okay.
emphasize, Mr. Rahul.
Okay. Yeah. Thank you, sir.
Okay, thank you.
Uh, like we have a question in the chat box. He was asked. It was like, how does an ammonium nitrate smell? Like, what is the smell of ammonium nitrate?
Right, okay, this is what I'm expecting. Right, okay, it is very interesting. And actually, it is quite crystalline solid. Right, it is nothing but, how can I compare it with the smell with others? I'm not able to explain it because of I smelled once in laboratory, but in this case, how can I explain it to you? This is what something very new for me. Just what I'm trying to say, I'm not able to answer this because the smell, it is white crystalline in color, but the smell, I'm very interesting about that. Hope in future I will send you the smell because of the smell, which means I compare it with any of other naturally obtained products. So that if I see it in any naturally obtained product, yeah, that smell is similar to the ammonium nitrate, then we will understand about that. I'm very sorry. Actually, actually now I'm not able to compare the smell with any of the stuff that happened. Really, I'm very sorry. Right, okay. Next question. If there is any question from inboxes.
In the absence of further questions, in the absence of further question, I think I thank everyone for their participation.
Any question?
I thank everyone for their participation. Oh, there is one more question. Sorry to interrupt.
I see it. Okay.
It was
yeah.
what are the health consequences of ammonium nitrate explosion? Sorry. So we'll finish it up after this.
Yeah. Yes. I saw it. Mr. Tamal Ilakian, answer to your question is, first of all, I appreciate you asking this question. Through the explosion, nitrogen dioxide, right? Okay. Nitrogen dioxide may emerge from this explosion. So, and you already know that nitrogen dioxide, which is NOx, right? It is also one of the pollutants which causes respiratory problem, especially respiratory problem. So, respiratory problem is one of the main consequences of this nitrogen dioxide, because the main product is nitrogen dioxide, and we already know that through vehicular exhaust, we may have an accumulation of sulfur dioxide and along with nitrogen dioxide. In addition to that, suppose if the explosion is caused in a very what I'm trying to say is in a very polluted city, it may increases the chance of respiratory problem. Like I hope you clearly understand what I'm trying to say to you. If you have any further clarification, then you can ask me, then I will be responsible to answer your question. Mr. Tamil, are you clear about my answer? If you have any query, then you can ask me. I will be waiting. Thank you, Mr. Tamil. Right, okay, and the question, the answer to a previous question, the smell of ammonium nitrate. Okay, actually it is odorless. To the best of my knowledge, it is odorless and it is colorless. In future I will explain it to you. Right. Thank you, Mr. Tamal Ilakian. Thank you for asking a question about that. If you have any question, then you can ask me.
Sir, mind if I interrupt you? I'm sorry, sir. I have another doubt.
No problem. You can ask me a question, Mr. Robert.
Yeah, but in my school days, I heard like it's a stench smell. So I might be wrong, but which chemical substance is stench smell? As stench smell, is that ammonia or ammonium?
Yes, I got your intention behind that question. But actually, ammonia is usually odorless. But
Okay.
the main role of ammonium nitrate is it is used as an oxidizer. Oxidizer in explosives. The main role of ammonium nitrate is itself is a best oxidizer. It can be used along with other chemicals also. Then only we can get a massive explosion. But you may smell that something you mentioned about some smell, right? Okay, that is due to the oxidation, which means oxidation with the surroundings. Actually, it does not happen, or it may be older copper. This is what.
Yeah, I'm not sure. I'm not sure though, sir. I'm just asking you. Just not sure about that.
Ammonium, yes. Okay, but ammonium nitrate in pristine quality is odorless in nature as well as in colorless.
Okay, sir.
Colorless or maybe Mr. Rahul.
Yeah, okay, sir. Thank you, sir.
Thank you for your question, Mr. Rahul.
Thank you, sir.
Thank you, Rahul.
I think in the absence of further questions, I thank all participants for their presence, and I wanted to say you that you all will receive an e-certificate in your mail as well as a feedback form for your valuable suggestions and comments. Thank you so much. Thank you for your participation. Thank you.
Yeah.
Thank you so much. Thank you so much. Right.
That was a good explanation, sir. Thank you.
Thank you, Mr. Rahul.